All right, so please write down these values so you know what masses we have available to us. Nero. Okay. The mass of the car is 0.5 kilograms. So you also want to know the mass of the car. So the mass in the middle here is 0.5 kilograms. So you have a bunch of different masses. And we're going to be looking at this thing called the Atwood machine. Okay. So this device is called an Atwood machine, where it's got kind of a car or a pulley in the middle, and then two masses, one mass on either side. Yep.
Are you supposed to write all those numbers on the side, like that conversion things?
Your choice. I mean, if you want to think about, because we're eventually going to have to convert these into newtons. So if you can go right from grams to newtons, go ahead. Otherwise, I would write down the kilograms also. Okay. Give everybody a moment to write those numbers down. Say again? Ah, gotcha. And we do have two 200-gram masses. We have two 200-gram masses. Like we've got two 20-gram masses, we have two 200s. Okay, and everybody has the mass of the car is 5.5 kilograms. Mass of the car is 0.5 kilograms. And then I'm going to zoom in and get our system going. Okay, here we go. I'm going to do the first one and the second one with you guys. And then as we keep going forward, you're going to get a little less information. Okay? So I won't be doing everything with you. I'll be doing some things with you. So on this one, a system is, what are we messing with, basically? And we've got a car that was 0.5 kilograms. So this section is going to be all mass stuff. And then over here, we have, since it's balanced, we had 200 grams, which was how many kilograms? 0.2 kilograms. And we're going to call this tension 1, because that's our first string, okay? And then over here, we also have 0.2 kilograms. And this is going to be tension 2. Does that kind of make sense? Okay. And just to fill this in, it did not move anywhere, right? It's not moving, therefore it's not going to get any time to go anywhere. Yep.
Where did you get the 0.2 from?
It is 200 grams. So each of the masses on each side that you guys have, I could have picked two different weights for two different masses, but the ones I picked because I had two of them was the 200. So the little black dangly things that are on there happen to be 200. Okay. All right. Now we should know how to do this part real easy. Okay. Force gravity, force normal. And if it's the car, how much is the car? Yes. it would be 5 newtons. So 0.5 kilograms times 10. That is going to be 5 newtons. And since it is equal up and equal down, this one is also 5 newtons. But now we have some new stuff, right? What's the new thing that we have to add? What do you think? I have tensions, and they're going to the sides, right? So T2 is going this way, and it's how many newtons? 2. 2 newtons. And that's going to be a lot smaller than 5, right? So this is FT2 is 2 newtons. And then we have FT1 is 1 newton, or sorry, 2 newtons. So is that all balanced? Yeah, everything is equal and opposite. So my net force equals 0. It is balanced and no motion. So you should be able to get that one. That one's old school. We've got that, right? We did that for the last few weeks. And now we're going to get some new information. All right. I'll wait for everybody to get that squared away. Okay, does anybody need more time? Okay, let me scroll this up. Okay, so now we have to create a situation where M1, mass 1 over here, is 2 times greater than mass 3. So what masses could we put on there to make this one twice as heavy as this? I've got a 200 on there now. That 200 is twice as heavy as what? Huh? 100. Okay, so M1 is twice the mass of M3. So if this is 200 over here, what does this have to be? If this is 1, yeah, this one's the heavy one. So over here is going to be the light one. So we need to find the 100. I think that is this one. Okay, I need you guys to hold that still. And don't let go. Okay. I need now, who has a timer? Go ahead. Open your timer. And
Timer or stopwatch?
Stopwatch, my bad. Let me go here. So let us go that way just a little bit. There we go. Okay. So when I say on your mark, get set, go, everything's good. They are going to let go. You'll hit start, and then when you hear one of the weights hit the door, stop. Okay? In this, the first one usually takes a second, or it takes some time. It goes fast, so we might have to redo it. Okay. Actually, not quite yet, because you're uneven now. Just one person. I think you're good. Okay. So for those of you that are at home, this side is heavier than this side. Okay? So on your mark, Get set. Go. Did you hear it? Okay, let's try that again. Okay, and if it's easier, you can even watch the video and see when it hits the floor. Okay, come this way just a little bit. Okay, there you go. All right, on your mark, get set, go. Woo! Did you get one? That's about right. Okay, so let's go here. Go here. So we had 0.7 0.77 seconds. We're going to need that for the end of the lab. Okay. Thanks, guys. All right, so oh, all right. So our system. Then we have, what was it? 0.5 kilograms. And M1. M1 was 200, right? Or 0.2 kilograms. And M3 was 0.1 kilograms. Did you get it?
I let go.
Yep.
Try the 200 thing.
Actually, you could probably put the really big one on top of the car and see if that'll do it. Well, it's still going to go, but just not as much. Put it in front of the car instead of next to it.
Then here?
The other side. The direction it's trying to go. It's got a magnet on it. Boom. Magical. We're smart. So this one is M1 and this one is M3, right? Cool. Or tension 1 if you wanted to, and tension 2, whatever.
What makes that M3?
They just, in the very top of the handout, there's like it's got it labeled in the picture.
Okay.
So like M1, M2, M3, they just did it in
I
order.
got really lost when you started bringing that.
Okay. Okay, do you see it at the top though?
Yes.
Okay, cool, thank you. Thank you for asking. Okay, clearly, was this balanced or unbalanced? Okay. It is now. So it is unbalanced. What direction did it end up going? Did it go towards, yeah, to the left, correct? So it accelerated. I'm hoping I have that on the screen over there. Cool. So it accelerated to the left. Now we have to draw our force diagram again. And we've got the same Fn, Fg, and those were 5 newtons. Same. Okay, now we're going to have some differences on the sides, right?
Yes.
How many newtons is the rightward one going to go? Show me with your fingers. This one. How many newtons is that one going to go? Okay. So it's going to go this way.
Wouldn't it be half as long as the
Yep. FT2 is 1 newton. Okay. And then this side is going to be how many newtons? Dos newtonos, right? 2 newtons. I just make up words. It's fine, right?
Yeah, I see.
So you're going to go like this. So this is FT1, and that is 2 newtons, right? Do I need to put equality marks or anything? No, because they're not equal, right? All right, my F net is going to be 2 minus 1. Yep. And it's going to be in what direction?
Left.
Okay, so it's going to be 1 newton left. Does that kind of make sense? It's not so bad, right? Especially since we just came from that. The fun thing that's going to happen in this unit is momentum, which is going to be the egg drop lab. So you guys, you take the egg, you drop it from high. Okay. Yeah, we're going to be doing that one this time. Okay, so the next one, are we okay here? Okay. Uh-oh. Come here. All right. So where M1 is 3 times heavier, the mass of M3. So what can we pick? If you look back at the masses that you've got, so M3 is going to be light, and M1 is going to be heavy. So what can we pick? If you look at those masses that I had you write down, what do you think we can pick? And we can stack masses if you need to. So you've got,
600 grams.
do we have enough for 600 grams? Do we have one? Okay. All right, so you guys have 200 over there. So you need 5 plus a 100. So that one is going to be 600, right? And this other one will be 200. So one side does not change.
The left side doesn't change, right?
Correct. That one does not change. It doesn't really matter, to be honest. So change one of the sides to be 600 grams. Yep. Okay, take the time while they're setting it up to sketch your system. Sketch your system. Okay. And we're going to need our timer again. Once we get there, it's going to get heavy, isn't it? So what do you got? You got 5 over there. So we still need another 100 over there. I think you've got 500 over there.
How do we know?
There's a little stamp on the
It
side.
says 100.
Yep.
We put a
So I can
500
put this
on.
on there?
Yep, because that would make it 600 and 200, right?
It's not gonna stay.
Oh.
Are we still little babies on it?
Yeah, put the little babies on it. All right, now here comes this here. All right, so we've got really heavy stuff over here and a lighter thing over there. I'm going to have you balance it out just a little bit more. Yes, Harley. Yeah. Go towards Eddie just a little bit more. Like, take a look, make sure that those are kind of evensies. That looks pretty good. Okay, are we ready with a timer yet?
Yep, I'm ready.
So you're going to listen for when the big crash happens. Okay, shake it out. Be ready. You ready? Okay, on your mark. Get set. Go. Right? 0.78? Let's do that one again.
Is this even?
Yeah.
Why was that, Ross?
I think it was a little on the slow end.
Okay, tell them again.
Okay. On your mark. Get set. Go.
142?
That's better.
You were a little off the first time.
Yeah, and it's so hard. So this one was 0.42.
Can we like take stuff out?
All right, now you guys should be able to do this, this, and that on your own using what we did together.
That's like negative.
Nope, just 0.42.
Oh, I was about to say.
So it would be 0.6 on the one side and then 0.2 on the other side, right?
Right. Okay, then we're going to add masses to the top. This is going to be about 500. So just go with it.
And go slower.
So,
Uh-huh.
the left side. On the right.
This one is heavier, whichever one is. Yeah, so just make that one better. No! Hi. For yours is- So make sure that that is. Yes, I like that this is even bigger than that, and this is, I like it. So you see how this arrow needs to be long.
1148.
So do we get out of here?
1150, 1148.
And this one's really short, because it's only 2. And this one, this size one is long, it's 6. This is gonna be longer than that.
What do you think of that? What is that?
Yeah, so what is the big difference on this? I know a lot of people saw, is the 5 newtons that you have up and down the longest vector? Nope.
I put 6 as the long.
6 is the longest vector. So back here, 6 newtons is the longest vector. And that should be going in what direction? To the left, I think. Is that the direction that we had it up there? Yeah.
Jeff's really good at this.
Sweet. All right, next up, You're home. Okay, this guy here. We have added masses to the car. We made the car heavier. Okay? We made the car heavier. And then we have to have M1 twice as big as M3. So M1, I think when we did that before, let me look. We used a 200 and a 100, right? So let's redo that one. So the car is heavier. So the car is heavier. And then we had M1, M2. So this is 200 grams. And this is 100 grams.
This,
Does that make sense? Okay. Now while they're setting it up, we've got to get our system sketched with the masses.
It
Okay.
needs to be 200, 100.
200, 100. Yep. Okay. Are we ready with our timers?
Yeah.
Are you sure? Okay.
Don't mess it up this time.
Oh, go back that way a little bit. There we go. Okay. On your mark. Get set. Go. Did you get it?
1.1.
Okay. So 1.1 second for the crash to happen. Now you guys should be able to finish the rest. Yes. Yeah.
Wait, how heavy is the car supposed to be?
The car is now, man, it was 5 newtons before. Now the car is 10 newtons. The car is now 10 newtons. Because we added masses to the car.
Do I do 1 kilogram?
Oops, not that one. What a who what now? Gonna do what?
Oh, yeah.
I totally didn't even hear what he said.
Is she going to get her keys?
I don't know. Maybe towards the end of the hour.
Let's.
It's the end of the
It's
It's the end of the hour. Well, she might come in a different hour then.
She's going to be on the phone.
They're at the castle, right?
Yeah.
Well, they're kind of not tucked in at the start. Unless you get
That's too funny.
What would the newtons be for 0.1 kilograms?
44.
How many? 0.1 kilograms is how many newtons?
He said 40.
I'm like, it is not 44. Uno, 1.
How did you not know? That's crazy.
I've been thinking about that.
Just that one, I got 0.3 on my tires.
Nice.
I know.
Okay. So are we ready for the next one or not yet? Okay. It's going to be like perfect timing. It's going to be perfect timing because we're going to have enough time to do this one. And then I'm going to be able to run you through this. And then the rest is homework. Okay. So we have 100 and 200 again, right? I'm going to go like this. And we are going to add another, or you just didn't get the second half.
Maybe that.
That's all it is you didn't get the second half. There you go.
Thank you.
All right, so now we added another kilogram to this. So another kilogram would make that car how many newtons? Because the car itself was a half. We added masses, so now it's 10 newtons. And then we doubled it. So now our car's our car's weight is 20 newtons. Our car's weight is now 20 newtons. Okay, let's even those up. Yep. Okay, I think we're good. Yeah. Okay, just let it go. Or not the car. Don't let the car go, but string. Okay, on your mark, get set, go. Tick.
1.3.
Okay. So now I'm going to go back over here. This was, 1.3 seconds.
What is the mass of the car now?
What is the mass of the car now?
2 kg.
20 newtons. They are in the classroom. They are not on a student this time. No, a student does not have them this time. Back.
Do I should climb?
I don't think so. Okay, so you guys should be able to finish that part up. Not in a cabinet.
There is something. There's in the classroom. Hey, they're in the classroom.
So with the this one and the mass, the focus 20 newtons is 0.2 kilograms, right?
Correct.
So that one's 0.2 kilograms too. So would they be the same?
20 newtons
No,
is
it's not.
2
It's
kilograms.
2 kilograms, not
Oh,
20.
this one is.
That the car is 2 kilograms.
What? You know,
We're in something?
They're in something. You don't really have to climb though. You're pretty warm though. Oh yeah. Cooling down a little. Cooling down.
Cooling down.
Hot.
Burning.
Yeah.
You're on fire. El fuego. La fuego? I don't know.
We're in something?
Yeah.
Are they that high?
No. Student doesn't have them. Cooling down.
I'm cooling down.
Yep.
God. Are they in the castle?
I don't know. Maybe a little.
Maybe a little.
Maybe a little climbing.
Okay.
Bye.
Yeah, I think this one and the last one are uneven because they're still.
Yes.
Okay.
Yep. Okay. Now we've got to get our speed. And I've heard a lot of observations already saying, oh, it's going to go slower here. It's going to go faster here. It's going to go something. I've heard that discussion a little bit. So our speed on our first one is distance over time. We're going to say that the car went 20 centimeters in every situation, okay? So every distance is going to be 20 centimeters. Every distance is going to be 20 centimeters. It's the time that will be different. So you have to pull your times from each of the situations. Does that make sense?
Yeah.
Okay. So sort that out. And then you guys have to do that part and 2 through 4 on your own. They're not tough. It's just
How much time do you have?
Yeah.
I'll just-
yeah, I think you've got about 2 minutes.